So like we'll directly like jump into the things like the concept of like powertrain and what is like powertrain and the sizing of those concepts. Okay. So first, like we look into the agenda. Uh, yeah. So like we'll be like getting to know like what are the forces will be acting on your vehicle. So we'll be like trying to get to know like different type of resistive forces and like how to estimate them or like how to calculate the forces. Okay. And then like we'll come into the driveline dynamics. So under this, like we'll be discussing about transmission system, like motor system, like battery system. So exactly like we'll be like discussing about sizing the components. Okay, like how like you might be thinking like what is the component sizing. Okay, so here let's say like if you want your vehicle like to move with this speed and this torque kind of thing, right? So you should be knowing like how much power has to be supplied from the battery side and then to the motor, and the motor will be able to provide that much of like torque and the speed. Okay, which are the requirements at the wheel side. So those like will be like parameters which we size. Okay, so that like refers to the component sizing. Yeah, so we'll discuss them like how to estimate them, like we'll look into the equations part, and later like we'll try to plot the things in the Excel sheet. Okay, yeah. So first like we'll start with vehicle body and driveline dynamics. Here I'm going to like explain that we are going to follow an approach that is wheel to well analysis. Wheel to well. Okay. So here like wheel to well, this is a vehicle body that refers to wheel side, and this is your battery, a kind of well or like a source you can say. So whatever the power you are going to supply to your wheel for your vehicle motion, that is through battery itself. So the approach, like as I mentioned, from wheel to well. So what exactly it means? So the things required at the wheel side. Let's say like a lot of resistance will be at the wheel. So for the vehicle movement, right? So in order to overcome like how much power has to be delivered, like the torque requirements, like speed requirements, all the stuff. So that will be estimated at the wheel side first, and like in the reverse direction or like in the backward facing, we will be coming. So getting to know at the wheel side, we'll be like going for transmission sizing and then to the motor sizing and then to the finally battery sizing. Okay. So what exactly at the required at the wheel, that much we are designing at the battery side. So this is how like backward facing goes. Okay. Yeah. So now like we look into start looking into the vehicle body part as first. So just try to remember this whole block flow. Okay. So we'll start with the vehicle body part, like as I defined the longitudinal dynamics. So yeah. So longitudinal dynamics, like it will just take care of the front and the back motion. So if you want to like take care of the turning, the curves, their lateral dynamics will come into play. Okay. Yeah. We are not dealing with that one. We are just like we'll be discussing about the longitudinal dynamics. So here, like with this figure, you can see we just like a forces has been like applied over the like let's say like this is your like aerodynamic force. If your vehicle is moving in this direction, aerodynamic force is it against your direction? Again, the rolling resistance and even the gradient resistance. So don't worry about the terms, like we'll discuss those things. Okay. So we are just balancing the whole equations at here, and we are deriving at some equation part at this point. So finally, like we'll be, let's say like F total equal to F net. F net is nothing but acceleration force plus F aero plus F roll plus F grade. So all are in Newton. Okay. So like they are forces. So we'll be like adding all the forces so we can get to know like total force required for the vehicle, or like whether it's moving in the desired speed. Okay. Yeah. So now like we look into like what exactly like rolling resistance, aerodynamic force, gradient force, like what they are. So I'll quickly like move to the next slide. So here first, like before getting into the equation part, like we'll just go through this pie chart, just as a knowledge. So aerodynamic force, like you can see, it's contributing about like 45%, and next to the rolling tire rolling, that is nothing but a rolling resistance, and rest others are like drivetrain losses and brake pad and wheel hub. Okay, these are like some resistance in terms of like percentage, which is a kind of forces acting on your vehicle. Okay, so this particular graph will be like referring to the forces, like and with respect to the speed. So we'll get to know like as we move to the next part of the slides. Yeah. So as we were discussing from the block side, like one is vehicle body, that is longitudinal dynamics, and then transmission. Okay, let me write it properly here. And motor and battery. So in the vehicle body, like we have to discuss about resistive forces. Okay, yeah. So first, like we start with like rolling resistance. So here, like rolling resistance, like as your wheel comes in contact, like with the wheel, like your like vehicle wheel comes in contact with some road surface. So a kind of resistance will be offered to your wheel rotation, to the wheel movement. Okay, so a lot of parameters is going to affect your like wheel resistance. Okay, the rolling resistance. So we'll discuss like those parameters. First parameter, the design of your wheel. So like your wheel, let's say like the width of the wheel. Okay, and a big width of the wheel, and like a little bit smaller width of the wheel. Okay, so if you try to compare like different width of the wheel, like which is going to offer with a more rolling resistance, so I will go with the bigger width of wheel because the contact patch will be higher in the bigger width of the wheel, because as the area increases, like contact patch is nothing but uh, this is the contact patch. Okay, so like at what point the wheel is in contact with the uh, surface. Okay, the road surface. So if the bigger the width, like higher the area of your contact patch, so compared to the smaller width of your wheel. So one is with respect to the design, like design of your wheel, or like size, and one more like weight. weight has a parameter, and the tire pressure. Okay, so you can see in this particular graph, like there is like in the y-axis there is a coefficient of rolling resistance, the term, or like we'll discuss that one, and on the other side, like x-axis, like car speed, and the y-axis of the other side, that is the right side, this is y and y dash x. So they have mentioned about like tire pressures here. Okay, so here you can see like how the tire pressure like they are affecting. Like higher the tire pressure, like the lower will be your coefficient value. Coefficient is nothing but a constant value. Okay, but as the speed increases, like the particular coefficient value, like it's also like going to affect. Okay, it's going to increase. Okay, yeah. So like the parameters are like tire pressure, like weight, and the width. Okay, and also the other parameters like the road surfaces. So take the same tire, the material and everything, or try to roll over the different surfaces like concrete, sand, road. Like it depends. Again, this particular value is going to be varied. So that is also a kind of parameter. Okay, and the temperature. So has the like higher the temperature, there will be a lot of hysteresis losses. Okay, so as you apply the force on your tire, like somewhat like the graph, it's going to come like in this pattern, and as you release, okay, it will come back at the same point with this much of loss. Okay, so this is your wheel. So when this particular point is in contact with like road surface, is nothing but you are applying the pressure on it. So a, a pressure is added, and once like has the vehicle or the wheel makes a rotation, this particular part will come at here. So at that time, like it will come back to its like the pressure, or like as you release the stress graph. So but it will take a deviation. It's not going to come at the same like line. So whatever like the gap or the area between two lines, we can say that a loss of energy. So it's going to happen like again with different tube like material of the tire. So that you can see it. One of the effect of rolling resistance, the tube material, or sorry, the tire material is also has to be considered. Okay, yeah. So like we just looked into some parameters like dimension of your wheel, weight, um, and pressure, and also it depends on the speed of your vehicle and the different material of your tube. Okay, and the different surfaces which is in contact with. So all these parameters will be affecting your rolling resistance. Okay, so many parameters it will be included and defined with some constant value, that is CRR, coefficient of rolling resistance. So here we can discuss the equation. This is a generic equation. So here CRR value we will be considering as constant. Okay, in the generic equation. In the real time case, it will be varying. Okay, you can make use of this equation or like to define the CRR. So it's going to depend on like tire pressure and the velocity. So it is inversely proportional with the tire pressure and directly proportional to velocity. Okay, yeah. So for our estimations, like we'll be using this particular equation. Okay. So just make a note of this equation. We're going to make use of this equation. So here you might be wondering, like, what is CRR? CRR is nothing but a coefficient of rolling distance. FR is rolling force or the resistive rolling force kind of. And GVW, it is nothing but gross vehicle weight. Okay, gross vehicle weight is defined with gross vehicle mass and AG. AG is nothing but acceleration due to gravity. So gross vehicle mass is defined with uh, driver mass plus vehicle mass. So this gives you gross vehicle mass. And if you multiply the gross vehicle mass with acceleration due to gravity, you will end up with gross vehicle weight. Okay. Yeah. So all are like ended with like unit in the Newton. Yeah. Now, like we look into the aerodynamic force. So, like quickly, I will just define this. What exactly the aerodynamic force? Okay. So here, like if this is your vehicle, so as it is moving, it's going to oppose with some air against your vehicle motion as the vehicle moves. So whatever the air molecules come in contact with the surface of your vehicle, they try to create a resistance to your vehicle motion. In reality, you are not going to like see how the resistance is affecting, but that you can feel when it comes to the estimating the range. So if there is no aerodynamic force, like let's say like there is no wind acting on your vehicle, so what will be the range of your vehicle, and if the wind acting against your vehicle, then what will be the range. So in that way we can like decide. Okay. Yeah. So here like a basic like generic equation, that is aerodynamic force 0.5 rho. Rho is nothing but air density. A is nothing but frontal area of your vehicle. So like if this is your vehicle, right? So whatever the frontal weight, if I see it in the side view, it might come in this part. Okay, like the whole thing is like front view. Okay, yeah. So here, like this is a like generic equation, uh, and the CD is nothing but like coefficient of drag. Like I will explain this like what exactly it means, and the v square, that is velocity of your vehicle at which velocity it's moving. So one thing you have to make a notice that all the terms are directly proportional to the aerodynamic force. If anyone is like increasing or decreasing, uh, like it's going to affect directly to the force value. Okay. Yeah. So here, like coefficient of drag, like it's just a constant value, which will be defining uh, the drag. It is a dimensionless value. Okay. So how we can calculate these particular values, or like we'll just look into them. Okay. Yeah. So here, like there are some other equations I have mentioned. So this is your general equation, and when you're trying to move your vehicle, like against your wind, which is blowing, okay, with some uh, velocity, okay, then we have to include that also while we are estimating the aerodynamic force. Like if you are moving against the wind, and if you are like the wind is along the direction which you are moving, then we have to like subtract it. And in the same way, there are a lot of parameters will be considered. for the typical sizing of your traction motor and the battery, we'll be using this particular equation. Okay, yeah. So just make a note of this equation. Okay. So we'll discuss about like dependencies. So here, like what the things are going to affect your aerodynamic force. First, like as we named it as like drag dependencies. So drag CD value is directly proportional with respect to the aerodynamic force. So you can see the different shape of some object will be having different drag coefficient. Okay. So if you see like last 2 points, that is streamline body and the half streamline body, like they're having very less drag coefficient. So this is why the aerofoil structure of your like planes, or like if you consider the rocket, like and like the boat in the seas, okay, and the car, they are almost in the streamlined body shape. Okay, so with the others, you can see the square or like angle, cube, like cylinder, it is having like lot of drag coefficient. So this is why like vehicle body like always tends to have like streamlined body. Yeah. And as we discussed, like aero force, that is aerodynamic force, is directly proportional to the v square. If you see in the equation. So as the velocity of your vehicle increases, the force on the vehicle is going to increase. Okay. And the same with respect to the air density. If we go to the like Rajasthan side, like which is a very hot kind of thing. So the air density will be like very less. As the temperature increases, the air density decreases. If you go to some like Kashmir side, like the air will be like it's very cold and the air density will be like very high as the temperature decreases. So even this will also like affect your um, aerodynamic force. Okay. Yeah. So there are some drag coefficients, like different types of drags. Like one is with respect to skin friction drag, pressure drag, interference drag, all this stuff. So just look into them. Like take it as an assignment part from your side. Just try to look into them, what exactly they mean. Okay. Yeah. And the same goes with the like the drag coefficient estimation. So here, like if you consider the same equation, F arrow equal to 0.5 CD rho multiplied with like frontal area and V square. So if you assign all the parameters to the LHS side, so equation will be like CD equal to F arrow divided by 0.5 rho and okay 0.5 rho frontal area and V square. So you will be like free defining the things and you are going to do this estimation and you are going to end up with some a non-dimensionless value. So that you can consider it as a drag coefficient. So like these are like some real-time method and this is some tool-based method through CFT we can achieve. Okay. Yeah. So the final like the equation you can make use of this one for our calculation. Okay. So next like we'll discuss about like gradient. Okay. So we just go to this slide. So here like gradient force. So let's say that like if you are riding your vehicle on just flat surface, so anyhow like you have, in order to overcome your static conditions, you have to put some effort. So that is some part of effort has to be put. When you're trying to climb your hill, a climb hill condition, so is the same like effort is going to help you like to climb up the hill. Okay, so there comes like a resistance, like we can say that is a gradient force. Okay, a grade angle is nothing but inclination angle of the road with respect to its like previous part of the road, like ground level road. Okay, so how it's going to affect, like as you like one is like the grade is affecting. Okay, uh, if you are like on the flat road, if the grade is affecting, it will be completely um, like 90-degree with respect to your horizontal road. Okay, so if it is on the inclination, the force is also like will be lying towards its ground with some angle. So this particular angle and this particular angle will be equal. Okay, so this angle, like we use it as a grade angle. Okay, yeah. So if you're trying to drive a vehicle on the uphill condition, you need to put more effort. When you're trying to draw in the downhill condition, like there is no like effort is needed. So you're going to subtract your gradient force. Okay, so you can see a gradient assistance in the downhill condition and uphill condition a gradient resistance. Okay, yeah. So here this is your like final equation to calculate the gradient. So you might be wondering like what exactly the plus or minus. So if you are riding uphill condition, then you have to add your gradient force. If you are like downhill condition, you have to subtract your gradient force. So if you subtract like from the total force, like very less force will be left again, so that we can use it for the sizing the component. Okay. Yeah. So one like acceleration force, like the force equal to mass into acceleration. This is nothing but a basic Newton law. Okay. Yeah. Like gross vehicle mass is multiplied with acceleration. How this acceleration can be derived? So anyhow, like you are going to feed a velocity profile when we are trying to estimate the things, right? So you are going to feed some velocity profile. From there, like you are going to get acceleration through, let's say, like what exactly it means acceleration, like a rate of change of velocity, right? So with respect to the time. So if you know like v2 value, that is velocity 2, velocity 1 divided by t2 minus t1. So yeah, this is your like velocity value. So yeah. So with this you can identify or like estimate your acceleration. Then you can multiply with your GVM. So you will get acceleration force. So once we know all these forces, like we will add up all the forces. So we have calculated aerodynamic force, rolling force, gradient force, acceleration force. So we are going to add all the forces. So that is nothing but total tractive force. So this is the total force required at the wheel side. Okay. So with that force, like you are going to multiply with like total tractive force multiply with wheel radius. Okay. So here it should be wheel radius. So you are going to get wheel top. So force is in Newton, like radius of wheel will be mentioned in meter. So it is nothing but Newton meter. So torque unit is like Newton meter. And we can like also calculate the wheel speed. So like converting into like linear speed into the RPM. Okay. So this is the particular equation. Velocity is multiplied with 60 divided by 2 pi r. R is nothing but wheel radius. Okay. So if you remember this particular block, transmission, motor, and vehicle body. So output of your vehicle body, here you are going to get uh, wheel torque and wheel speed. Okay. Yeah. So once you get to know like what is wheel torque and wheel speed, you are going to feed. Okay, don't worry about these things. We're going to feed them in the like transmission system model. Okay, so output of your transmission is motor torque and the motor speed. So input to the transmission system is like wheel speed and the wheel torque. So here you are going to define your like gear ratio and transmission efficiency, all the stuff, and then you are going to calculate the motor speed and the motor torque. So you are going to make use of these equations. Okay, so we'll be redefining the gear ratio, yeah, and this transmission efficiency. So next, like if you know the torque and the RPM parameter, we can make use of that equation 2 pi nt upon 60. So nt, like n is nothing but the speed, motor speed, t is nothing but the motor torque. So you can get to know motor output power. So this is your motor block transmission. So here you can estimate motor output power. So if you know like motor efficiency, you can estimate the motor input power. Okay, so we'll just look into that. So here you can go for motor power estimation, that is motor output power. So in order to like know the efficiency of your motor, you can calculate the motor input power. Okay, so here where you are going to get the motor power, the input side. So the battery is going to supply. So again, between motor and the battery, there is some term that is motor controller. So even there will be some losses at the motor controller. Okay, let's say like your battery is giving 100 watt and output of your motor controller is 90 watt. Okay, so here a 10% loss. I'm just taking a random example. Okay, so here it means like it is 90% efficient. Like again, for the motor input power, if you divide with the motor controller efficiency, then you are going to get the battery power. Okay, yeah. So this is how like the approach we are going to follow. Let me show those equations. So this is like battery power BBP BPP. So if you know the motor input power divided with the motor control efficiency, you can estimate the battery power. Yeah. So just let me know like if you have any like clarification on the equation side, like before going into the calculation part. Just type it in the chat box. motor controller efficiency. Yeah. Yeah, we can also do that thing. Okay. Like, yeah. So with respect to the motor controller efficiency, here, like, let's say like this is your motor, this is your battery. There is a motor controller. It's nothing but a PCB. Okay. So it will be like having like MOSFETs, resistors, like all the stuff, right? The electronic stuff. So when you're trying to pass some electricity through them, there will be a loss called QR losses. Sorry, I squared R losses. Okay. So like these losses, like they're going to heat up the component. So it's going to emit out some heat energy. So heat energy is nothing but a energy, right? So there is some loss. So that loss, like we consider it as a efficiency. Okay. So if you include that, like you are going to finally end up with a BPP, that is battery power. Okay. So I hope you have like noted all the equations. So let me jump to the like calculation part. Okay. So uh, just let us know, like if you have received this particular file in the chat box, just type yes. Okay. Just create a new sheet here. In the new sheet, just go or like assigning some parameters. Okay, we'll just try to do it quickly. Yeah. So just go on typing. You can make or just try to put it here. So input parameters. Okay. And values. So CR like first we'll like start with vehicle mass. We are taking some random vehicle mass here. Like that is 111 kg. So just try to write units from your side at C column and driver mass. So like 70. Wheel radius. Point 0.1524 and grade angle. So here we'll be considering grade angle as 0. Okay, it means the road condition is flat. There is no like uphill condition or like downhill condition. And air density. Okay, and frontal area. Air density, like it is 1.22. Frontal area is 0.875. Or like diameter, frontal area. Okay, then like go for gear ratio and transmission efficiency. Trans or dash EFF means transmission efficiency. And the same thing for motor efficiency. Like XLS like the file like it has been shared to your mail. Okay, yeah, just look into your mail. So next, motor efficiency and motor controller efficiency. Okay, and coefficient of drag, we'll just mention it as CD. Now like, so we'll just put the values 7.8, transmission efficiency as 0.85, motor efficiency at 0.9. Okay, motor control efficiency 0.85. Yeah. CD 0.22. Okay, so here I will be estimating gross vehicle mass. So we look into like gross vehicle mass. Like if you want to say that what exactly the equation, that is vehicle mass plus driver mass. Okay, so here you have like vehicle mass and the driver mass. So you need to add it here. So we'll just make it automatic here. Just put the equal sign, select 111, that is B2, add a plus symbol and select the driver mass, say enter. So it will add up by itself. If you change, let's say like I will make it 100, and if I say enter, so that changes you are going to like also affected on the other side where you have used the particular terms. Okay, so I'll just keep it 11 itself, 111, say enter. So 181. So here I'm going to define G value, that is acceleration due to gravity, that is 9.81, and GVW. So here you need to define GVM multiplied with G. Say enter. So this is your like gross vehicle weight. Okay. So these are like some of the input parameters. So yeah. So I will go to the drive cycle sheet. I'll just copy both, Control C, come back to sheet 1. I'll paste it here. Okay. So once you are done, like just let me put it here, a graph. So this is your like velocity versus time. That is nothing but a drive cycle. So how you can define the drive cycle? So drive cycle is defined as like it is nothing but a velocity upon time. So it will be having some varying velocities and with respect to the time. Okay. So like it contains like irrespective of like velocity variables. So you can like calculate for, instead of going for each velocity calculation, you can like go for like multiple velocities. So can get to know like what are the torque, the continuous torque or the peak torque. You can estimate all those things. Okay. Yeah. This drive cycle is NEDC drive cycle. Okay. Yeah. These are like standard drive cycles. Okay. Like you can make use of any drive cycles. Just get to know like what are the like components is. That's it. So when you're trying to manufacture or your own vehicle, so you have to test and collect the drive cycles as per the city condition. Okay. Or like for if you are trying to manufacture for India, so you have to collect the different drive cycles of your like all the states and try to put it. Okay. Yeah. So now like we'll quickly try to put the equations here. So first we'll convert the velocity, like the presently the velocity is in meter per second. Sorry, kph. So first we'll convert into uh, meter per second. So here equal sign, select this velocity, kilometer per hour. You can multiply with 1000 and then divide with 3600. Say enter. Okay, and double click at this particular point. Okay, if it doesn't work, just drag it. Like for first time, we have to, I think we have to drag it. Later, it will come by itself. Okay, so this is velocities in meter per second. So now I will calculate the wheel speed. So here to the wheel speed, like we'll select the velocity which is in meter per second multiplied with 60 divided by, bring the open bracket, 2 pi, that is 3.142 multiplied with r, that is radius of a wheel. You can select this particular wheel. So in order, if you say like it has to be like r value constantly, it has to be multiplied for all the set of data throughout your like drive cycle data. Okay, so if you try to like drag it here, so it will also go on taking the different values here. Okay, so it has to be multiplied constantly to the drive cycle here. So I need to make the changes here. So here I need to add a dollar symbol before and after B. Okay, and then close the bracket, say enter. So then just drag to the end. Okay, so you will end up with some like results, the wheel speed. Yeah, now like we'll try to put some like resistive force equations. So first like we'll try to place aerodynamic force. Okay, so here the equation is 0.5 multiplied with rho. So like have we mentioned the rho? Let me check. Yeah, air density. So 1.2. Add a dollar symbol before and after B. And multiply with the frontal area. Again, add a dollar symbol. Okay. Multiply with like now CD, a dollar symbol. And now multiply with velocity. V. Again multiply with velocity. Okay. So V square. There is also other option like power of 2. Okay. For now, you can just like multiply 2 times so that it will give you like V square value. So just say enter. You are ended up with some results. So if you just drag to end, you're going to get some data. Okay. Yeah. So this is your like uh, aerodynamic force. Okay. Yeah. Now, like we can calculate rolling force. So here in the rolling force, like what is the equation for rolling resistance or like to estimation? GVW multiplied with CRR. Okay. So I think I haven't mentioned CRR. So just try to mention it here. CRR equal to 0.015. Yeah. So here rolling resistance or like GVW, this one, add a dollar symbol. Okay. And now multiply with CRR, that is 0.015, add dollar symbol. Okay. And then say enter. So this value is going to be repeated like continuously. So just double click on the dot, like you will get to know. Okay, it will be like repeated. So it will be like repeated because no other parameters affecting your like values like CRR and GVW, like they are considered as a constant. So yeah. So to represent like the next force, that is gradient. So we know the equation, that is mg like GVW multiplied with sine theta. So theta, like we define it as a angle as 0. So the output you're going to get sine of 0, you will get a 0. So multiplying with GVW, so you will end up with like 0. So for now, like we'll just neglect this like gradient force. Okay. So anyhow, like you are going to get 0. So now, like we'll try to estimate acceleration force. So we know like we went through the equation, that is V2 minus V1 like divided by T2 minus T1 kind of equation to estimate the acceleration, multiply with the GVM. So here equal to like V4, just bring the bracket here, minus V2 divided by 2. Okay. So here again in the equation, multiply with the force. So sorry, mass, that is 181. Add a dollar symbol. Yeah. So just say enter. Okay. Now you can see like the acceleration force. Okay. Yeah. Now like we have estimated acceleration force. Now like we can go for total tractive force. So total tractive force, like we need to add all the forces, right? So I'll just mention TTF as heading. So here equal sign, just go for selecting aerodynamic force, rolling force, sorry, aerodynamic force plus rolling force plus acceleration force. Say enter and just bring the drop down here. Okay. So once you got to know TTF, that is total tractive force, you can go for estimating wheel torque. So wheel torque. Okay. So wheel torque, total tractive force multiplied with wheel radius. So wheel radius, you can find it here. So for the wheel radius, we have to add like dollar symbol, because it has to be multiplied constantly throughout your drive cycle data. Say enter. Yeah. So once you got to know wheel torque and the wheel speed, okay, you can estimate your like motor torque and the motor speed. Okay. So let me put motor torque. So in the motor torque, like the equation is wheel torque divided by gear ratio multiplied with transmission efficiency. So wheel torque, we are going to get it here. It has to be divided from, it has to be divided by gear ratio and the transmission efficiency. So wheel torque divided by gear ratio. So bring the dollar symbol for both, and efficiency 0.85. So just select, bring a dollar symbol, because like these are not varying with respect to time. Okay, so these are like constant. So for that purpose, we are adding dollar symbol. So it has to be like used in the estimation constantly. Say enter. So if I say enter, yeah. Now, like we got to know like motor torque. To calculate wheel speed, multiply wheels, sorry, motor speed. So multiply wheel speed with let gear ratio. Wheel speed multiplied with gear ratio. Okay. So yeah, say enter. Sorry, I need to mention heading here instead of equation. Copy, and I have to paste it here. Copy, delete, paste it here to remove this Q2. Yeah, say enter. Here, motor speed. Yeah, this is your like motor speed. So you got to know like motor torque and the motor speed. Then like we need to calculate motor power. So the basic equation, the mechanical equation to calculate motor power, that is 2 pi nt upon 60. So equal to 2 pi 3.142 2 pi n nt. It is nothing but motor RPM. Select this one, and torque divided by 60. Say enter. So this is a like motor power. So this is motor output power. So we have to calculate motor input power. Okay. So to calculate input power, we have to divide motor output power by your motor efficiency. And even if you include like motor controller efficiency, you will end up with the battery power. So directly I will include both efficiency, battery, to estimate the battery power. Okay. So equal to motor power divided by, one is motor efficiency add a, sorry, let me go there. Add a dollar symbol before and after B. So again, bring a star mark and then multiply with the motor control efficiency. Bring a dollar symbol, close the bracket, say enter. So this is your like battery power. Okay. So like motor speed, motor power, and the battery power. So again, you can like go for multiplying the power with respect to the time. It is nothing but integrating the power with respect to time. You are going to get battery energy. Okay. So let me put some graphs here. Okay. Here, what I have done, motor power divided by. So whatever the power here you're getting, right, this is motor output power. To get input power, you have to divide with the efficiency, that motor efficiency. Okay, you will get the motor input power. So again, if you include the motor controller efficiency, you will end up with getting the battery power. Okay, yeah. So like this completes like your like up to the battery power. Okay, so let me put some graphs here. Go to insert, select a recommended graph, select or like however you want, and bring motor torque, motor speed, motor power, and battery power. Like it resembles the same thing. Like it's not an like worry to see that particular graph. It reflects the same pattern of your motor power. Okay, yeah. So this is your like velocity profile. In order to achieve, see, you can see at some points like it has reached the 50 km speed and some point like 80. So in order to reach like the speed, so some point of acceleration also has to be given, right? Okay, so including like all the considerations to reach this required or the desired velocity values, some acceleration, some effort has to be put. Okay, so these are like requirements of your motor. Okay, and also from your motor speed RPM side. So as you like go at the higher speed, your torque requirements is goes on decreasing. So this is your like torque characteristics curve, right? Like I hope you have seen in the earlier sessions. So motor versus speed. So initially the torque requirement will be high, and like as it goes on increasing the RPM. So as the RPM of your motors increases, you can see the torque is like very less. Okay. So these spikes because of maybe of sudden accelerations, and so even if you consider at motor high speed of your motor, like high power is required. There you can see. So this is a range like 4 to 6 continuous torque range. These are like peak torque ranges, like peak torques. The same with respect to the motor power, the continuous power requirement, and the peak and the same with respect to the motor speed. So yeah, these are like some important graphs which I have shown here. So if you have any doubts, just let me know. Okay. I'll just stop recording.